Hey gamers, we're back with another episode of Let's Create a Competitive Card Game. In this episode, we will be continuing with the theme of game balance by coming up with a way to auto-generate the stats for the cards. So let's go ahead and get started. Alright, so last episode we discussed cost curves, and I talked about what exactly a cost curve is, and I also discussed how to come up with cost curves and how they work by using games like Versus System and MTG as examples. Now, we also came into the cards spreadsheet and assigned semi-random costs to the followers in here. And I say semi-random as I have played a lot of different card games, so I do have a general idea of how many cards of a particular cost each class should have. Now, one way to come up with the cost for your cards is to first determine how long do you want your game to be. Now, for this specific game, I don't want it to go any longer than, say, 30 to 45 minutes. Now, with that, something to also think about is, in a tournament setting, is it best 2 of 3, or is it just whoever wins the first matchup is the winner? Now, one way to sort of either increase the amount of time that the game is played or to decrease the amount of time in which the game is played is to kind of set a maximum cost for your cards, and those will be sort of game-breaking effects or bombs for that cost. Now, to give an example, let's use Versus System again. And again, I did play this game when it very first came out. So when it came out, the maximum cost was 20. And once you played a card that cost 20, the effects were essentially game breaking, or they were bomb cards. And as an example, some of the effects were, once a card came into play, it would destroy all of the resources, or quote-unquote mana, in play, which means that both players would be starting at 1 from then on, which means you couldn't really get rid of this card the turn in which it was played. Another effect was, once a cost 20 card entered play, it would destroy all other characters in play. Now, another example is, let's say, the spoils. Now, their game-breaking costs or game-breaking effects start at cost 10. Now, there are a few cards that go above cost 10, but in general, in the spoils, if you play a card with cost 10, that's considered the bomb, and that's when the game-breaking effects happen. And those effects are effects like taking control of all of your opponent's cards and things of that nature. So for this game, I did set it at 7, and obviously there will need to be some play testing done for that. And depending on if games are running long or short, I may need to either increase or decrease the cost of cards. Now, for this episode, what I want to do again is come up with a way to auto-generate these stats for cards. Now, what exactly does that mean? So what I mean is I want to come up with a way to generate the attack and defense. And that can be done mainly because we do have a cost-benefit analysis, which allows us to balance out the cost and benefits. So we did write down all of the effects, and we wrote down either a benefit or cost for those. And also, since last episode, we did come in here and create cost for cards. Really, all we have to do is attempt to balance the cost with the benefits. So if a card has more cost than benefits, then we need to add attack and defense so that they balance out. And if a card has, say, more benefits than cost, then we either need to increase the cost in order to give the card some attack and defense, or we need to decrease the benefits to allow us to give the card some attack and defense. So now, with that said, how are we going to go about auto-generating a way to do this? So one way you could do this is you could write a script. Now, I'm not going to write a script. I'm actually just going to write a program. Now, on this computer, I have NetBeans and I have Android Studio. So we will be using NetBeans for this. So I'll go ahead and hop over it. Alright, so we're in NetBeans and this is version 8.2, so I haven't used NetBeans in a very long time. I think this version came out in 2015 or 16. So yeah, let's just go ahead and get started. So first, we'll just go ahead and create a new project. And yeah, this is in Java. This should be interesting. Alright, so we're just going to call this, let's say, Mythical Stat Generator. And this should just give us the classes for this. Alright, so now before we start, I do want to say that this may be a long episode as I have an idea in mind of what I want to do. However, I do not actually script any of these episodes. I just go off the top of my head, and since this is coding, there may be some mistakes, etc. And also, I want to say that I will not be doing proper coding. I will not be doing any architectural patterns, so there will not be any MVP, MVVM, any VM, or anything like that. I won't really be doing any object-oriented programming, so there won't be any encapsulation or anything of that matter. This will just be me writing code essentially as quickly as possible to get done what I need to be done. And then maybe in the future, I'll go back and clean this code up. So yeah, don't judge the quality of the code here. And also, I should mention that I'm not really going to be explaining, say, what is an integer, what is a string. I'm not going to be explaining any of that. I'm just going to be writing code. So if you don't know how to program, then you may not be able to follow along. Or if you're interested in programming, hey, you may want to follow. But yeah, let's go ahead and get started. So what is the idea behind this program? So given some cost and some benefits, I want to be able to generate the attack and defense. Now, the way I want this to be generated is, let's say a list. So I want the attack, comma, defense. So in order to do that, we're going to first need to know a few things. Now, let's say we're going to need to know the cost of the cards. Now, there are two resources in this game. Therefore, there will be what I'm going to call a primary and a secondary resource. Now, remember, last episode we talked about cost curves and how with Magic, for instance, the more mana a card had, the more benefits it would have. And it wasn't linear, it was sort of exponential. And so I did come up with a couple of equations for this specific game. So what I'll do now is I'm just going to make some variables and I'm going to instantiate them. So these are just things that the program will need to know in order to output some data. So we'll need to know how many primary costs the card has, or we need to know the number of primary costs, the number of secondary costs. We won't need to know the total, but the program will need to get the total given the primary and secondary. That way we know how many attack and defense points we need to give out. So we'll also need to know any benefits, and yeah, all of this is just integers. And I'm just going to instantiate them at 0 now, so I don't have to worry about it later. So next, we'll probably need to know any negative cost. And again, a negative cost is the same thing as saying the benefit, but for this, I want it to be specifically different. So with respect to the game, a negative cost would be, say you have to play a card, but you can reduce the cost by doing something else. So it is a benefit, you get to play the card cheaper. So that is essentially what that is. And next we'll say something like a negative benefit. And a negative benefit is a benefit that harms you, the player of the card. So yeah, we have primary, secondary, totals, benefits, and let's just call it benefit, negative cost, and negative benefits. So something else, and this may give away the formula I have, but we're going to need to know if it is a power card or not. So it's really not it won't be a secret. You'll be able to figure this out if you look at the card, but I'll just tell you now. In this game, cards of the Power Guild will be more powerful than Mind or Life. And by more powerful, I mean they will have stronger attack and defense, while Life and Mind will have maybe more benefits or slightly better effects. So it's not a drastically stronger card, it's like slightly more attack and defense on average. So we have this information now. Now, something else that we're going to need, since we're going to be taking input, is we're going to need a scanner. So we'll just do the basic scanner.scan equals, and we'll set it to be a new scanner, and that needs to take some input from the system. So let's just say system pattern, and it would help if I spelled this right. And this is red. So yeah, we need to import the scanner, and this just comes from Java utils. Alright, so we have this scanner, and we want to get a list. So again, I'm just trying to instantiate everything that I know I'm going to need. So we're going to need a list, and we're going to need it everywhere. So this is bad practice, don't do this, but I'm going to go ahead and make a static list. And you know what? Let's just make it a map. So we'll do a static map, and we're going to need some string and an integer, which will just be the values for the attack and defense. And yeah, very unique naming here. We're just going to call it hash. And again, we need to import that, which is also Java utils again, I believe. Alright, so what else do we want to do? So before I forget, let me go ahead and instantiate this hash. That would suck to forget to instantiate it. So let's set it to be a new hash map, and we'll set it again to be just same thing, string integer, as we are instantiating it. And we'll just set it to be hash map. So we need to hash map, and I bet you guys probably guessed it, but yeah, Java utils. Alright, so we have all of the variables that we're going to need in order to get this program to work. So now, how does this program work? So first of all, we're going to have to take some input from the user, or from myself. And since I'm the only one that's going to be using this program, I'm going to, again, not make it super complicated, I guess. So we're going to need to print a line, which is system.println. I just thought of something. This is going to get very repetitive, and I don't want to do that because that's bad practice. So I'm just going to make a static method. Again, don't do static methods, not very great. And I'll just call it print line. I shouldn't say not very great, it's not good practice. And you know what? Let's go ahead and take in the scanner. Let's take in the message that we want to give to myself. And let's take in the property that we want to set. And here, and so I don't have to keep writing, what is it, system.out.println. I'll just do that here, and I'll say, hey, print this message. And you know what? I'll set this property, since they're all integers. I'll just set the property to enter, or to equal the next scan next in. And that should work. Alright, so actually no. We have a boolean here, so that won't actually work for the Boolean, so this will be the only other time we need to, I shouldn't say that, but I'm going to do system.out.print here. And I'm just going to say something like, is this a power card? And since I'm the only one using this, I'll just say 1 equals that. Now, this would crash if they entered, say, a character or anything. I'm not going to do any try catches. I'm not going to throw any exceptions, anything like that. Again, this is just going to be very, very basic. So we'll say 1 equals yes. And yeah, we just need to set the value for this power. And we'll just set it to the next integer. And it's a Boolean, so we'll just check to see if it equals 1, and that will set it to true or false for us. Now, the next thing we need to do is, and let me separate this here. Next thing we need to do is essentially get the values for everything else. So we need the value for primary, secondary, benefits, negative cost, and also negative benefits. So for all the rest of these, I'm just going to use this method or function, whatever you want to call it. I'm going to pass the scanner, and the message for the first one will be, let's say, how many primary points. And right, the property is primary, so this will set it for us. And you know what? This is bad practice. Don't do this. I'm gonna say that a lot. And I'm just going to copy and paste this for secondary benefits, negative cost, and negative benefits. So I'll copy it out. And let's just say how many secondary points. And after secondary points, primary, secondary, let's say primary, secondary, let's say benefits. How many benefits? So we have primary, secondary benefits. Let's say how many negative costs. I'm not sure why this isn't filling in. Sometimes it auto fills, but it isn't today. So we have negative costs. Let's see how many negative benefits. All right, so we should be setting all of the values, such as benefit, benefits, primary, secondary, benefit, negative cost, and negative benefits. So now that we have all of these values, something we can do, actually, we can set the value of total since we have primary and secondary. And total is just going to be the combined total of primary and secondary. And this will help us determine how many points are left over to assign to any attack and defense. So now that we have this, we need to determine what the cost is. So yeah, we know how many primary, we know how many secondary, but remember, there is some equation to determine the actual cost of the card. And since we have is power here, we know that the equation is different for power, so we need to do something different if it is power. Now, the information here for the formula and the equation for calculating this, I don't actually want to reveal that information. So what I'm going to do is I'm just going to make a new class, and yep, I will call it, let's call it Mythical Utils. And what I'm going to do is I'm going to put some methods in here. So we need two methods. We need one specific to, let's say, power, and one specific to non-power cards. So again, don't make static methods, and we're just going to call it static, let's say get power follower. And I'll just show how you can create it, but I won't actually put the code inside the method. Or you know what, I'll put the code inside the method, but I won't show it over here. How about that? So for this method, we're going to need to know essentially all the other values, and then we'll calculate and set what the cost is. We're going to know the value for primary. We're going to need to know the value for secondary. We're going to need to know the value for benefit. We're going to need to know the value for negative cost and the value for negative benefit. So all the other values that we already have. So let's go with negative. Yeah, let's go with negative costs first, and then let's say negative. And yeah, again, copying is bad when you're coding. Don't do it. And we're gonna just say non-power. So yeah. Now what I'm gonna do is I'm going to go ahead and put some code in here, but I won't show it on camera. And when I'm finished, I'll go ahead and hop back over to the stat generator. So I'll be back in a second. Alright, so I'm back over at the stat generator, and something else that we do need is we have the total, but we do need a reference to the cost, as it will be used throughout this class. So let's go ahead and just do a static, let's call it cost, and we can just instantiate it to be 0 for now. Alright, so now we added the methods over here to Mythical Util, so whenever it is power, we can just say Mythical Utils dot, and we'll say get power follower, and okay, yeah, it's auto populating now, so that is good. And we can do the same thing, Mythical Utils dot, we'll say get non-power follower. So we are good here for getting the cost. So these methods, all they're going to do is we have the total, so they're just going to set what the cost is, and so we'll have the cost and the total. So now that we have this, what do we want to do now? What I want to do now is, remember, I want to see a list that has a value for an attack and a defense side by side. So we're going to need, say, an array. So the array, we're going to need two values, so an attack and defense. So one way we can do this is we can make a string array, and you know, for now I'll just call it set, and I'll set it equal to a new string array, and we'll say the value will be the cost plus 1, and that's because arrays start at 0 index. So the idea behind this will be, we'll get the cost plus 1, so say the cost is 2, so we'll get 3, and what I want to do with these values here is I want to go ahead and assign them. So let's see, this won't be a for each or the extended for, so let's do the code for. So let's say for int I equals, let's say for int I equals 0, while I is less than the length of the set, so while I is less than set length, we'll just do I++. And all we're going to do is we're going to set the value of I to just be equal to the string value of I. So we're just going to concatenate a string on there. So yeah, so we're just making the array have strings and have the values. So now that we have the array of potential values, we'll go ahead and make an array that will contain the stats, or you know what, I would call it strength. So shorthand for strength. And we'll just set it to be a new string with, let's say, we need 2 places. So yeah, we have K there, so we can just set it to a new string array of 2. So now that we have these, we actually need to write the code to create this list. So for the code, let's see, I'm going to make a method. I'm going to call it, what do I want to call this? Let's call it generate, because it's going to generate the list for us. Now, what do we need for this method? We're going to need to know how many values, so attack and defense. So we can just pass an integer k, and I'm going to name them the same just so I know what values to pass here. So we're going to need the set array, and we're also going to need the strength array. And we're also going to need to know the index. So just to give some context of what I'm trying to accomplish here, what I want to have printed out is I want an array that's a 0, no, we're not going to say 0, 0 because it's attack, comma, defense. And if you have 0 defense, you die, so no cards can have 0 defense. So I want an array that will print from 0, and remember, we set the value to be cost plus 1 of the set. So if the cost is 2, then we'll set it to be 3 plus 1, so we'll have 0, 1, 2. So 2 is a little low, so let's use 4. So yeah. So we'll have 0, 1, 0, 2, and we'll have 0, 3, all the way up to, and then when we're finished with the zeros, we'll go 1, 1, 2, 2, or sorry, 1, 1, 1, 2, 1, 3, and then 2, 1, 2, 2, and all the way up to, let's say, we're going to have 0, 4 in the zeros, so we'd probably have something like 3, 1, because that equals 4, and we'll probably have something like 1, 3. So that is the idea behind this method, is I just want a list so I can look at the attacks and defense. So now, with this being dynamic, the amount of values and the total cost, the best way to do this is probably to use some form of recursion. So let's just set the endpoint here. So whenever the index is equal to k, so whenever it's equal to 2 or 1, as it's -1 for index, that's where we're going to want to do some breakout stuff, and otherwise we want to perform some logic. So what is the final step that we want to do? And that's what we do when the index is equal to k. So what we want to do is we just want to put the value on a, or in the hash, on the hash, in the hash, however you want to say it. So the value that we're going to put here is really just the value of the strength array, as that's going to be the 0, 0. Now this is a hash, so it's key value pairs. So we're going to have to do what is it? Arrays dot, I think, toString. Yep, arrays.toString, and we're just going to put the value of string here, and that will be the key, and the actual value that we put on here will be the combined value, so we know what the total cost is. So like a 0 1 is 1, or let me say this a different way. A 1 1 is 1, and a 0 2, or 1 1 is a total of 2, and a 0 2 is a total of 2. So essentially, we just want the combined value of the attack and defense. So we can just say integer. We want a string, so let's just say value integer dot value of, and we'll do left right, so 0, and we'll say plus integer dot value of, and we'll go with the right hand side. So yeah, this should be the last point. Now, we imported array, so that's good. All right, so now when we're not in the break statement, we want to go for each value in the set. So the total cost is the total number of values in the set. So we just want to say for everything in this set, so we could do like for each, we could just do this for it's just a string. So let's say string set 1, and sorry, I like my spaces in set. So for every set inside of this set, we want to add that value. So this will let us do 0 1, 0 2, 0 3, 0 4, and something to think about is we don't want a 0 in the second spot, as that is defense. So whenever there's a 0, we want to skip it, or rather we want to continue. So we can say if the index is 1, as that is the second spot, if index is equal to 1, and the value of the set is equal to 0, then we need to continue. So yeah, so let's say something like string dot, and yeah, let's go string dot value of, let's say set 1, and we'll do dot equals, and we'll say, since we're doing strings, now there's other ways to do this, but this is just how I'm doing it right now. So if the index is 1 and set 1 is 0, then we just need to skip this. Otherwise, we can set the index, or the string for this particular index, to be equal to whatever the value of set 1 is. And again, that's set 1. So if you're not a programmer, you're not used to coding, I know this can be a little bit complicated. But again, set 1 is just the cause plus 1, and you'll see how this works in a second. So yeah, and yeah, once we've set that value, then we just need to do it all over again. So this is why I'm doing it recursively. That way we don't have to keep writing all the code. The code will call itself. And this will just be the value of k, the set, the strength, and the index. All right, and let me see. Actually, no, not the index. Otherwise, we'll just keep doing the same thing over and over. So we need to do the index plus 1. So once we have this, we now know how to generate that array. So we can just call it. And the reason I named these the exact same is now I just know what to pass. See, I can just pass K, you can pass step, you can pass strength, and we're going to start at index 0, so we can just hard code that value there. So now we can run this code, and let me just make sure. Alright, so we'll take in all the values, we'll get what the cost is, we have the total, and we'll get to set and we'll generate it. Okay, so this actually isn't going to print anything out, as, yeah, we didn't tell it to print anything out. So let's just go ahead and for now we'll just do that right here. So let's go to system.out and we'll just print a line. And this is just going to be exactly what I wanted it to be to begin with. So remember, I just want the values in this array, so attack and defense. So attack will be 0, and we'll do a string concatenation, and let's add a space, and the value of 1 for the first index. And how about this? We can put what the total cost is, as that would be interesting to see, as a higher total means that you have overall better stats, or you have a better stat lineup, if that makes sense. And we'll say the total is really just the product of string 0 and string 1. So we just need to add those together. So we can just do integer, and we'll do 0 first, and yeah, we can just do that, and we can say plus the value of, let's say, integer value of, and we'll use the first one. And yeah, this should be good. Now, what's going on here? There we go. Add an extra, add an equal sign when I need a plus. So technically, I should be able to run this and not typo. And yeah, hopefully this will not crash. So let's just see what happens. Alright, so we'll say yes, it's a power card. 1, 1. Alright, so, and actually, if you slow that down and look at the numbers I put in and look at this output here, you'll actually be able to maybe deduce the formula I have. But yeah, so this is exactly what we want. So we say, okay, we have a power card. It has a primary cost of 1 and it has a secondary cost point as well. It has no benefits, it has no negative cost, and no negative benefits. So essentially, this is just a vanilla card. Now, at the minimum, the stats, given that it has no other costs or benefits, can be 0, 1, and at the high end, it could be 2, 2. Now, I do not like the way this printed out. Yeah, I don't like the way this looks. Okay, so, you know, what I'm going to do is, I'm going to, let me think about this. I'm going to sort this hash. It probably would have been easier if I did an array, but yeah. I'm going to sort this, as that is going to get a little bit annoying looking at this. So How do I want to do this? So let's just make it unique. And let me think about this. This is a hash, and we want to sort it by, it's a key value pair, so we want to sort the hash by value. So, hash is a comparable, and we can pass in, or we can just say what the key or value is, so that it extends a comparable. And we can, you know what, we can do this. We can do it this way. We can say, we'll use some generics here. And then we can say, we can say that it is a map with a key. And let's just call this, let's just say sort by value. That's what we're going to do. We're going to sort it by value. And we're going to say that we're going to say that we need a we need a map, really. So we're going to need some map with a key and a value. So, yeah, this will be good. We can do it this way. So we need to return something. So we're going to return some results. Now, I'm trying to think of how to sort this. So there's a few ways we can do this. So how about this? Let's just say we have a list. All right. So we have a list that has let's say it has a map and it has some entry. And again, it's not anything, it's just a key value. And we have this map, we have this list. We're just going to call it list, and we'll go ahead and instantiate it to a new, it'll have to be a linked list. Yeah, I didn't really want to get into this, it's not really complex, but I didn't really want to go this deep into coding this, but I really do not like the way that looks. So yeah, we can say it's going to be some entry set. And alright, so again, we need to do some input. And most of this is just Java utils again. So Java utils list. And we need Java utils. What did I use? Ruthless. So I'm not sure as to why it's giving me this issue. But I will find out. Anyway, we can just go ahead and proceed. So anyway, we can just say it is a collection, because we can do sorts on collection, so we don't have to do any super complicated logic. So we can just say, hey, sort this list, and let's make it a new comparator. And again, it's just a map and a entry with a key and a value. And you know what? Let's just there we go. All right. So, what exactly do we want to do here? So, all right. I don't want to see all this red, so let me go ahead and import the rest of this. So we have let's see, Java utils. I used a comparator, and we import Java dot util dot, what else did I use? A parent collections. Let me see, what else did I use? You know, technically we can just instantiate the result now, just to get it out the way. Really, all I'm going to return is a map, as that's really all that list is. So I can just set the result to equal a new, let's say a linked hash map. Yeah, so we could just set it to be a hash map. Just pass it this way. Did I spell that wrong? And again, here goes another import. Yeah, this episode is running a little bit longer. I'm not sure if anyone's going to watch this long, but yeah. Maybe I spelled that wrong. C-O-M, I believe it is just the exact same. C-O-M-P-A-R-A-T-O-R. Yeah. Alright, so again, we have this list. And did I import list? Yep. Interesting. So yeah, we have this list that just has some entry and a key and a value. And yeah, we need two of those, and we just set it to be a list. We say it is again a new linked list, which is a map and an entry set, which is interesting. That's interesting. Anyway, so it's just this new entry set. Then we're just going to do collections.sort and make sure we have that linked list. Yeah, I'm honestly not sure why it's still red. It's probably something super simple. Let me see. Alright, anyway, so yeah, so we have this collection here, and there's this method, what is it called? Compare. So we need to override the compare method, and since it's red, it's not going to do it. So I'll just do it here and figure out what's wrong here. So this method is just a public, and it's an integer that it returns, and it just will compare some values. So what it actually compares is the two positions on the map. So essentially it's just going to compare the left and the right. So we need the entry for the map, and again it's just a key and a value, and we'll just call this 0, 1, why not? And we need the second one. So again, that's just another map.entry, and again let's use a key value, and we'll call it 0, 2. And yeah, we can just, since we have to return something, we can just return, we want height alone. So we can just say something like o2.getValue, o2.getValue, and yeah, we can return this, and then we can compare to o1.getValue. Yeah, we can compare it to o1.getValue. And this should work. I'm not sure. Oh, you know what? New mistake. It's a map.entry. Yeah, that was a super noob mistake. Yeah, map.entry. I thought I was pushing dot, but I was actually just pushing comma. So anyway, this is a overwrite method, and again, spelled overwrite. Alright, so all this is going to do is compare the values of this hash map, and then it's going to put it in descending order. So, or that's the idea, is that it should put it in descending order. So yeah, once we've generated this, we need to sort this hash map. So we can just say the hash map is equal to hash map and what is it? Sort by value. And then I can just hash the hash itself to sort itself. And yeah, we want to maybe print this a little bit cleaner. So let's say this. Let's say for every entry in this map. So for every entry in this map, and it is a string and an integer. And we'll just call it entry. We're going to, yep, we're going to yep, the entry for this hash. We're just going to say that essentially if, right, if it's less than or equal to the cost, then we're going to print it out. Yeah. So if it's less than or equal to, it's less than or equal to cost, we'll just do system.out.print. And what we're going to print is we're just going to get the value, as everything is already stored the way we want it to, as we did that inside of generate, and then yeah, we'll just concatenate it, and yeah, the value and the key. Again, it's all stored the way we want it to, as in this generate method. That's sort of how we went ahead and just put it on there. So we can just comment out this, and yeah, so this should output the way we want. So this is how it output the first time. Now, so we'll do the same things, and so it didn't print out this time. So am I missing something? Let me see. We're going to sort it by value. We're going to do the entry for everyone in the hash entry set. If the value is less than or equal to the cost, then we're going to print out with whatever that value is. That's good. Let me see. So yeah, we need to get the list, get the entry up. Should be a new linked list. We're gonna get the collections. Then we're gonna do o2.getValue, and we're going to compare it to o1.getValue. Then we have this new map, which is a new linked list. I forgot something here. So we just set it to be an empty list, but what we need to do is say that, for instance, int I, let's set I to be 1, because yeah, and what we need to do is we need to go through this. So here, let's do this, and by this I mean the entries in the list. So we need to go through the list. So let's just say map.entry, and we'll do it this way. Where is it, generic something? And we'll just call it entry inside of this list, and we'll just put it on the result. As you can, there's nothing actually on the result, which is why nothing's actually being printed out, as we were just returning an empty hash. So we'll say entry data. What do we want? We want the key and value. All right, now let's try that one more time. Alright, so the same thing. There we go. Now, you see, we don't get all the extra stuff now. As, ooh, this gives you even more information as to how I'm doing the formula for this. So yeah, we got out before, we got all the way up to, I believe, 4, but now we're putting out values that aren't valid based on the formula that I have here. So one thing that's going to get annoying also is having to input this multiple times, so I have to keep restarting the program. So I honestly don't want to keep having to restart this, so something really simple to do is exactly that. Let's just say we'll do all of this, and let me just make sure I line this up. We'll do all of this, and we'll say while let's say while and yeah, while primary does not equal 0. Now, this is definitely 100% not the best way to do this, but just to demonstrate, this will work. So again, I'll use the same values. So 1, 1, and I missed a 1. So that should have kept going. Now, I'm not sure why it didn't keep going that time. Let me just make sure I did this right. Yep, so we have this hash map here. Let's see what I do. Oh, of course. What is this code? So you're going to there. Erase this. Do is going to here. Q, yeah, I know what it is. I know what it is. It's the way I'm setting the value for primary. Yeah. So yeah, it's because of how I'm setting primary in this method. So let's say, let me give it 72000. Yeah. Okay. So how do I want to fix this? So one thing I could do really quick is just do this. Yeah, sorry, some programming languages are, some of them you can pass by reference or pass by value. There we go. Yeah. Yep. So yeah, you can kind of look through this and figure out what the formula is. And yeah, like I just said, some programming languages are different. Some has a reference to a point in memory, and some has the actual value. So sometimes you're just modifying the actual value at a specific point in memory, and other times you're just modifying the value that is being passed. So while this was a good idea, since it's in this method, it's really not changing anything. I would have to either make it static or just keep it out. So what I'm going to do is I'll just do this really quick just to finish up here. And let's do this. How many primary? Let's say how many secondary? How many benefits? Negative cost. And negative benefits. And yeah, I'm gonna need to change these. So this should be secondary. What is this? This should be, is it benefit? This should be negative cost. And this should be negative benefit. And yeah, negative benefit, negative cost. All right. So this should work now. And let me make sure I hit everything still. Negative cost, benefit. Yep. just cancel the running of that. And yeah, let's just rerun this. And yep, so let's go 1, 1, yeah. And you see, it's just going to keep asking me again. And now, let me make sure this is right. So, let's see. Yeah, it's right now. Yep, it's right. Alright, so this is how you can create a program to auto-generate stats for you. Now, again, you do need to know some specific things, which are the things that you will assign in effects, like the cost and the benefits, etc. And then from there, this will generate attack and defense for you. Now, things like life, those are considered benefits. It doesn't benefit for a card other than a class card to have life. So yeah, this will work perfectly going forward. Now, this will be all for this episode, and I'm going to go ahead and apologize, as I'm pretty sure this is a fairly long episode. And if you're still watching, I definitely appreciate it. And if you like these episodes, be sure to like, subscribe, and all of that other good stuff. And also, if you do want to see more episodes with coding, or you want me to maybe go more in depth in this code or clean it up, do leave a comment and let me know. Alright, so thanks guys.